Our today's lesson is solving quadratics by factoring, where the leading coefficient is 1. Solving quadratic equations with a leading coefficient of 1 can be solved by factoring. Let's first review how to factor trinomials with a leading coefficient of 1. For example, we have y squared plus 3y minus 4. And you want to focus on the second term and the constant. Make a little diamond chart. The constant's negative 4. And the coefficient of the linear term is 3. So what two numbers multiply to negative 4, but at the same time have a sum of 3? And if you think about that, that has to be 4 and negative 1. So because 4 times negative 1 is negative 4, and 4 plus negative 1 is positive 3. So these are your factors. So you're going to put y plus 4. You're going to put y minus 1. If you multiply that like we did in the previous lesson, you're going to get y squared plus 3y minus 4. All right, factor q squared plus 25q plus 100. All right, you're going to do the same thing. You're going to look at the coefficient of the linear term, that's 25. The constant's 100. So what two numbers multiply to 100, but at the same time have a sum of 25? And if you think about that, that has to be 20 and 5. Because 20 times 5 is 100. But if I add 20 plus 5, I get 25. So my two factors would be q plus 20 and q plus 5, because that multiplies back to that trinomial. All right, how do we solve equations with the coefficient of 1? Well, you're going to factor this, and you're going to set the two factors equal to 0. So if you look at this, I have a 16 for the constant, and my coefficient of the linear term is 8. So what two numbers multiply to 16, but at the same time have a sum of 8? So if you think about that, that has to be 4 and 4. 4 times 4 is 16, and 4 plus 4 is 8. And if you look at that carefully, this is a special type of factor there, because we call that a square. You have 4 and 4. So you're going to have m plus 4 times m plus 4, which equals 0. And in this case, since it's a square, you can really write this as m plus 4 squared equals 0. You're just going to set one factor equal to 0. So m plus 4 equals 0. M has to be negative 4. All right, solve n squared minus 10n equals 24. First thing you want to do is you want to put that in standard form. So you're going to subtract the 24 to both sides. So now we have n squared minus 10n minus 24 equals 0. And then you go through the same process. You have a negative 10 for the coefficient of the linear term, a negative 24 for the constant. So what two terms multiply to negative 24, but at the same time add up to negative 10? And you think about that, that should be 2 and negative 12. 2 times negative 12 is negative 24, but if you add them up, 2 plus negative 12 is negative 10. So those are your two factors. You're going to have n plus 2, n minus 12 equals 0. Set the two factors equal to 0. So n here has to be negative 2, and n here is positive 12. So we have negative 2 and 12. All right, solve y squared minus 25y equals 0. But notice you're missing the constant on this one. So what you can do, you can factor out the y's. So I'm going to take a y out of that, or I can divide y into both terms. And I'm left with y minus 25 equals 0. And again, I set both factors equal to 0. So y equals 0. That's one solution. You have y minus 25 equals 0, which is y is 25. So you have two solutions, y equals 0 and y is 25. All right, sometimes with functions, they'll ask you to find the zeros of the function. You might see it in this format, f of x equals x squared minus 4x minus 12. And find the zeros, you're going to set f of x equal to 0. So you have x squared minus 4x minus 12 equals 0. And you just solve this quadratic. So what two terms multiply to negative 12, but at the same time add up to negative 4? And that would be negative 6 and 2. Negative 6 times 2 is negative 12, but if you add negative 6 and 2, you get negative 4. So you have x minus 6, x minus 2, x plus 2. And you're going to set that equal to 0. All right, both terms set equal to 0, and then x is just the opposite of negative 6, is 6. X is the opposite of positive 2, that's negative 2. So the zeros are negative 2 and 6. All right, this concludes our lesson for today.